Hello everyone. Today we will be learning Numpy, which is a powerful library used for numerical and mathematical operations in Python. We will cover metric operations, mathematical functions, linear algebra concepts, and basic statistics. So let's start with the first topic, which is understanding what is matrix. So a matrix is a collection of numbers arranged in a rows and columns. In NumPy, we represent a matrix using a two-dimensional array. NumPy provides built-in functions that makes matrix operations very simple and fast. Here, at first, we have imported the essential library of NumPy. Then we have defined the matrix along with the elements that will be presented in it. Then we can clearly see that our matrix is being displayed. Now, in NumPy, there are some essential operations that includes addition of matrix, multiplication of matrix, and dot production. So let's start with the first one, which is addition. Matrix addition means adding the corresponding elements of two matrices. For matrix addition, both matrices must have the same dimension. Let's add matrix A plus matrix B. Here, 1 is added to 5, 2 is added to 6, and so on. NumPy automatically performs element-wise addition. Let's move on to the next operation, which is multiplication. The multiplication is called element-wise multiplication. Each element of matrix A is multiplied with the corresponding element of matrix B. Here we can clearly see that this is different from the actual matrix multiplication. The actual matrix multiplication comes under the dot product, which will be our next operation. Here, dot product follows proper matrix multiplication rule, where rows of the first matrix are multiplied with columns of the second matrix. We use the function of np dot dot. Here, dot product is widely used in linear algebra and machine learning. Now, moving on to the next part, which is related to mathematical operations. So, mathematical operations includes the floor function, field function, square root function, and cube root function. Let's start with the floor function. The floor function returns the nearest small integer. Let's define an array. Here we will use the function of np.floor under bracket the name. Here we can clearly see that it has returned the nearest smaller integer. Like for 2.3 it has returned 2, and 4.7 it has returned 4. Then for 6.1 it has returned 6. Now next one is seal. The seal function returns the nearest greater integer, and for that we will use the function np.seal along with array. Here we can clearly see that for 2.3 it has used the greater one, which is 3. Then same for 4.7 it has used 5, and for 6.1 it has used 7. Now moving on to the next part, which is the square root and cube root. We can easily calculate square roots and cube roots using the NumPy function. For square root, we use np.sqrt. Here, it has provided us the square root of the elements that are present in the array. Similarly, for cube root, we use np.cbrt. Now this has provided us this cube root of the given elements in the array. This operation works directly on arrays without using loops. Now moving on to the next part, which is the conditional operation using np.var. Here np.var is used to apply conditions on array. Let's say np.var along with the condition is greater than 4. Here the value is greater than 4, so will return high, or otherwise it will return low. So among the high and low, you can clearly see that for the first one, it had written the low. Then for the next, second, and third, which are greater than 4, it had written the value high and high. Now moving on to the next part, which is the linear algebra. Starting with the first topic, which is the matrix inversion. The inversion of matrix is a very important concept in linear algebra. It is used in solving questions and machine learning algorithms. Here, first of all, we have defined a matrix. Then we have used the function for the inversion. So here it has worked on inversing it. Now moving on to the next part, which is root of a polynomial. Roots are the values of x where a polynomial becomes 0. Here, first of all, we have provided the coefficients, which are the which are the elements of 1, 5, and 6. Now, this is going to provide us the roots of the equation, which is going to come 3 and 2. These are essential as this provides us the roots of the polynomial. Now, moving on to the next part, which is eigenvalues. Now, eigenvalues are special values related to a matrix that are widely used in data science and machine learning. And for this, we use the function of np.lij.eig. Now, this is going to provide us the eigen result. This function returns both eigenvalues as well as eigenvectors. Now, moving on to the next part, which is Numpy statistic. Let's make up the data and include the elements 10, 20, 30, 40, and 50. So our first point is mean. The mean is the average of all values in a data set, and it uses the function np.mean. Here we can clearly see that it has provided us the mean value as 30. Now next part is median. The median is the middle value after sorting the data, and for that we use the function np.median. Here it has provided us the results as 30. Now next one is the standard deviation. Standard deviation tells us how much the value vary from the mean. And for that, we use a function nt.std. Here, we are being provided with the standard deviation. Then comes the final one, which is variance. Here, variance is the square of standard deviation. And for that, we use the function of nt.var. Here, we are clearly being provided with the variance, which is the square root, which is the square of the standard deviation. So in today's session, we have learned how to perform matrix operations, mathematical calculations, linear algebra operations, and statistical analysis using Numpy. Numpy is a foundational library for data science and machine learning. So understanding these basics is very important. Thank you.